Okay. So while we wait for the chamber to get to a proper vacuum for deposition, I'm going to go over some troubleshooting stuff. So most common is going to be problems that are associated with power outages in the building. So when the power goes out, a lot of these circuits get knocked out as well. For example, almost always if the power goes out, this main vacuum control panel is going to turn off. You won't be able to tell because the power LED indicator is burnt out. But when you come in, it won't be running. You just have to press this power button again, and it will automatically go into an auto stop state, meaning we will open up the vent valve. From there, you can just turn on the auto start. It will vacuum down the chamber again, and it will kind of reset itself. Additionally, something that commonly happens when the power goes out is the turbo pump will go out. When this happens, it will go into an emergency operation where it utilizes battery power to spin the turbine down at a safe speed without damaging it, and then it will turn itself off. You may come in the next day and it's just not spinning. All you have to do is restart it. Additionally, it's possible where with extreme power outages, the mechanical pump will also get knocked off. And in that case, there is a reset right here. This is the motor control reset. This has happened before where basically this button will pop out. If the mechanical pump isn't running, you can just press this back in and it will restart the mechanical pump. That's most of the problems that you'll encounter with a power outage. There are also problems that you may encounter due to interlocks being tripped during a process. So if you trip interlocks during an E-beam deposition process, it's going to affect the relays in the high voltage source. So for example, you see all these lights here. These are the different interlocks that determine whether or not the electron beam will stay on. They should all be lit up or the system won't start. Additionally, if you're mid-process and you trip any of these interlocks, it will, first of all, it will automatically turn off the high voltage, so your process will just stop in the middle of it. And it's also very possible that it will mess up the relays in that high voltage source right there. This will kind of manifest as, you trying to start the step start switch on here, main circuit breaker. When you turn it on, you should see voltage pop up. See, right now it's not actually doing it. Oops. Basically, the problem here is that the relays in this high voltage source are pretty old. So basically, you have a step start circuit. If that gets tripped and it's not working properly, it may take a couple times for you to turn it off and on for the high voltage to pop up. The other problem that we've had with this is with the ion gauge controller. So these controllers are much more likely to go down than the actual gauges. This is all old circuitry. So we've had an issue in the past where basically this controller died and it just wasn't reading the gauge at all. What we did is we had an extra one of these. We sort of cannibalized parts from it, put it back together, and we got it to run again. So again, it's way more likely that the circuitry is going to go out than the ion gauge. The ion gauge is, a pretty simple thing, and it's basically like a light bulb too. You'll be able to see if the filament is damaged. Again, I mentioned before, don't press the ion tube button. That will, mess it up. You have to discharge the capacitors. Other than that, as far as troubleshooting, as the power goes out, you may have issues where your set points here get messed up or your recipes here get messed up. You just have to be mindful of that. It's possible that this stuff is going to get messed up, and you may have to reset it. So it's always good to have a backup log of what your recipes are and what you should set them to. So that's pretty much all of the issues that we've encountered with this system. There are other issues, of course, that could happen with it. If you have vacuum issues, it's always important to check all the pumps with a gauge that you know is working, check all the joints in the vacuum system, and determine where exactly the problem is. If you're having problems with the gun, it's always good to check every part of the gun so you have basically the high voltage source, and then you have the heating film, and then you have the tip. In any case, some of that stuff may be replaced, and usually that may be what the end result is of your troubleshooting. But in general, that's the most easy to approach troubleshooting and stuff that we can actually repair in here without getting replacement parts. So that's mostly it. Yeah, that's all the troubleshooting I have. Additionally, if you look in the back here, we have all of our gas and water sources for the system. Starting from the right, we have the drain cooling water, the positive cooling water, so it flows through the system to cool it. We have a vacuum that is not connected to anything, as you can see. Next, we have N95, nitrogen 95. This drives the pneumatics. So anything that's driven by pneumatic actuation, that comes from that source. Again, we have another compressed air that's not connected to anything. And then we have our nitrogen 99, which acts as our vent gas. Nitrogen 99 is used because it will not oxidize your metal. And in general, it will maintain the quality of your metal film as you vent the chamber.